Okay, the recording has been started. Please, someone confirm if my screen is also visible. Okay then. So we are discussing about the collection framework series, and yesterday the topic was about the hash map. So I hope the concept of hash map is very clear. So today we will discuss about the linked hash map. Okay, we will discuss what? We will discuss about the linked hash map. So let me close all the tabs. Okay. So let us do a small recap about the hash map. And if you look at the map interface, so this is how you can visualize the map interface and the hierarchy. So here we have the map interface, and the hash map has already been discussed in the yesterday's class, right? And today we are going to discuss about the linked hash map. So before starting this, let us do a small recap about hash map, right? The hash map says hash map implements the map interface, and it was introduced in JDK 1.2 version, right? So internally it is using the data structure called hash table data structure, right? And these maps, they always store the data in the form of what? Key value pairs. Key value pairs. So the hash map has a kind of functionality like it does not follow insertion order, and it does not follow the sorting order, right? And it will allow heterogeneous element. Heterogeneous means the elements, the different elements of different data types, and it is capable to allow one null value, right? And these are the additional things that we have: the initial capacity, the load factor we have discussed, and the synchronization about the hash map, and it is not a thread safe, and things like that. And these are the methods. Okay, all the methods that you have for hash map, that you have for map, is also applicable for hash map. And you have discussed about some constructors, and after this we have also completed the internal working of hash map, right? We have seen these things. Okay. So today we will understand a new topic, a new class by the name of linked hash map. We will understand what is linked hash map. The linked hash map is just like an hash map, but there is only one difference between the hash map and the linked hash map. Only one difference is that everything will remain same. Very easy, isn't it? That one difference is this hash map will not maintain insertion order. However, the linked hash map will maintain the insertion order. That is the only one difference, right? So let us try to write the difference first. Then we will understand about the linked hash map. The topic is linked hash map. This is our topic of discussion today. What is the difference? This is the one of the popular interview questions. What is the difference between hash map and the linked hash map? Okay, the first difference. So the hash map was introduced. Okay, the hash map was introduced in JDK 1.2 version. Okay, but the linked hash map was introduced a bit later, not exactly the 1.2 version. Linked hash map was introduced in the JDK 1.4 version. Linked hash map was introduced in the JDK 1.4 version. This is one of the differences that is observed. The second difference is the hash map follows. The hash map does not follow the insertion order. 1 minute, guys. Hash map does not follow insertion order. Okay, so linked hash map follows the insertion order. Linked hash map follows insertion order. Or I can say that linked hash map preserves the insertion order. Very simple, guys. If I go back to the program, so this program, this is yesterday's program. Let me remove all this. Okay, we do not want to deal with this. So So I have created an object by using the hash map. Okay, so I have inserted some data in the form of key value pair. So Russia as Moscow as the value, Canada as Ottawa, India as New Delhi, and Egypt as Cairo. If you look at the insertion order, the insertion order is Russia, Canada, India, and Egypt with respect to the key. Okay. So when I try to print the reference variable countries. Okay, if you see the output is in a different order. You get Canada followed by Egypt, followed by Russia, and followed by India because of the internal hashing mechanism. The insertion order is not preserved here. But when I try to add the same data by using the linked hash, I want to use linked hash map. I want to understand what exactly the difference is there between the hash map and the linked hash map. So this time I'm going with the linked hash map and I want to find the exact difference. Okay. If I print the reference variable countries, which is on top of linked hash map, which is of type linked hash map, so the insertion order is completely preserved. Don't you think so? See, Russia, followed by Canada, followed by India, followed by Egypt. This is the only major difference. But internally, so many things are happening that we are going to understand it today. Okay, if you get a question like this in the interview room, you should remember all the qualities of hash map. The only key difference is what? It was introduced in a different version. This is introduced in a different version. The second one is hash map does not follow insertion order. Linked hash map follows insertion order. Right? And the third difference. Okay, the hash map. I can say that the internal data structure of the hash map is hash table. It uses hash table internally to store the data in the form of key value pair. Right? However, the internal data structure of linked hash map is hash table plus it also uses doubly linked list. That's it. This is the only difference between the hash map and the linked hash map. If you get a question, this kind of question in the interview, you can answer these 3 points. Apart from this, okay, when you want to elaborate the explanation about the linked hash map, all the points that you have mentioned in the hash map is applicable for the linked hash map as well, but you need to do a small correction. How many points that we have drafted for hash map? There are 17 points. I'm going to copy and I'm going to paste all the 17 points in the linked hash map. I'm going to do a small correction. Okay, the linked hash map implements map interface, but linked hash map, this linked hash map is extending to hash map class. So this is one of the difference. Linked hash map extends hash map class. Hash map class. So by looking at the the hierarchy of hash map, I have drafted this part. Okay. About the version introduction, it was introduced in JDK 1.4, which we have discussed just now. Okay. And third point, okay, linked hash map internally uses a data structure called hash table plus doubly linked list. We have discussed about doubly linked list in the first classes of collection framework. If you want, you can repeat that video. Doubly linked list. Right. Fourth point, please be informed that the keys must be unique and the values can be duplicated. Same point is applicable for linked hash map also. Okay. Fifth point, hash map. Okay, instead of hash map, I need to use linked hash map. Linked hash map is going to have the unique keys, but the values can be duplicated. So by default, the linked hash map follows insertion order. Okay. Follows insertion order. This is the only difference, right? And linked hash map does not follow sorting order. You do not want to change that. And by default, heterogeneous elements are allowed at both key and values, even for the linked hash map. Okay, and this thing is also same for both hash map and the linked hash map. Only one null value is allowed. Okay, and the initial capacity is also same. The load factor is also same, and all these points are applicable for linked hash map. Right? And what are the constructors that you have for hash map? Same constructors are applied for linked hash map. Okay, I can copy and I can place the same thing for the linked hash map also. Linked hash map constructor. Okay, I just want to change it. Okay, linked hash map, linked hash map, linked hash map, and linked hash map. Okay, you have the control of specifying your own capacity. You have the control of specifying the own capacity as well as the load factor, right? You can also pass a map object. See, look at this constructor. We will discuss about this constructor. We already know the working of the functionality of these three constructors. So look at this constructor. So what I'm going to do here is, so I'm going to create an hash map here. Okay, this hash map is going to accept a key value pair in the form of string data type itself. Okay, I want to add countries here, original countries or actual countries, any meaningful name I am giving it, equal to new hash map. Okay, so what I'm doing is I'm adding some countries under the hash map object. So I want to change this to what? Actual countries dot put, actual countries dot put, actual countries dot put. So I'm adding objects, I'm adding data to the actual countries variable. After this, what I'm trying to do here is I'm just passing this reference variable actual countries to the constructor of linked hash map. Okay. I'm just passing the reference variable of hash map to the constructor of linked hash map. Okay, if I try to print this, if I try to print the reference variable of the hash map, the output is not going to be it is not going to follow the insertion order. Okay, but if I pass the same reference variable to the constructor, to the constructor parameter of linked hash map, I am going to get an output in the what? In which order? See, here this hash map internally it is going to follow the hashing mechanism, right? After following the hashing mechanism, it is going to say that it is going to maintain this order as an output. Okay, the same order will go as a variable parameter, will go as a parameter to the linked hash map. This by following the same order. So that is the reason we are getting the same order in the linked hash map, because this is the output of the hash map and the same output will be taken as an input to the linked hash map. So it is maintaining the insertion order of the output that was given by hash map. That's why the order is same. You cannot say that okay, it will follow this order. No, this order is already deprecated. Okay, this order is already deprecated and hash map is following its order according to the hashing mechanism, and it is giving this as an output. Okay, this output will go as an input to the linked hash map, right? And linked hash map thinks that this is the actual order, this is insertion order, and it is going to do what? It is going to give the same order, right? So for example, if I instead of hash map, if I change this to linked hash map, and if I change this to linked hash map, now the actual insertion order is going to get preserved. Okay, the order is what? Russia followed by Canada, followed by India, followed by Egypt, right? The same order has to be given to the console, isn't it? Russia, Canada, India, and Egypt. We're getting this. And you can also do the vice versa. You can pass the object of the linked hash map to the hash map. Okay, you can do this also. Okay, when you do this, so something is going to happen here. Insertion order is maintained here, insertion order is not maintained here. Why it is maintained here? Because this output is coming from the reference of linked hash map, and this output is coming from the reference of hash map, right? So this is the importance of which constructor? The linked hash map constructor, which is going to accept the map as an object. This one. So you can pass any map object, right? And when you talk about the methods, the same method is applicable for the linked hash map. The same method that you are using for hash map will also be applicable for the linked hash map. So we do not want to keep much explanation about these methods as well. Making sense? So methods inside linked hash map. The same methods that was utilized for hash map will be applicable for linked hash map. So there is nothing to be discussed, right? So these things are clear so far. Now we will understand the internal working of linked hash map. Okay, how linked hash map is able to preserve the insertion order. Why hash map is not able to preserve the insertion order, we got to know, but how the linked hash map is able to preserve the insertion order? A very very sensitive question, I guess, isn't it? How it is able to preserve the insertion order? We will understand that internally. To understand this, I am going to take the same example. Okay, so I have created an object of linked hash map. Let us understand this line by line. Let us understand this line by line. Okay, the first line. Okay, what is the first line that we have? Okay, I don't think we need this. Okay, and okay, let it be there. So this is our first line. The programmer has written a line, and this is the first line of the programmer. Right? What is the first line? Linked hash. An object has been created for the linked hash. Okay? It is accepting two data in the form of key value pair of string data type. String as a key and string as a value also. So because of this line, an array will be created of size 16. An array will be created of size 16 because the default size of linked hash map is 16. So an array will be created of size what? Of what size? Of size 16. Okay, like this. So this line has created this guys. So behind the scenes, an array has been created of what size? Of size 16. Okay. Okay, now focus here guys. Now what I want to do here, I want to add 4 countries. For the simplicity, I am keeping the program simple for the better understand. Okay, I want to add the country Russia, I want to add the country Canada, I want to add the country India, and I want to add the country Japan. So the value of Japan, which is value is representing the capital of the country, right? So Tokyo is going to be the value of Japan. Okay, I am adding 4 countries. How these 4 countries are going to get added? Okay, what I just said, linked hash map internally using what? Internally using hash table, which is using the hashing mechanism. Along with that, it is also using doubly linked list. Doubly linked list. Okay, so what are the sequence of developments that will happen behind the scenes? Sequence of developments. Okay, the key will be converted to, the key will be considered and it will be converted to an hash code. Right, we have discussed at that point yesterday. So what it is going to do? So what is the first line that we have? Okay, this is our first line, first statement. Focus here, this is our first statement. Okay, so what is the key? The key is Russia. Key is Russia. Okay, the key Russia. Russia will be, the key will be converted to an what? Hash code. This hash code will get a modular operation, and after doing the modular operation, you will get what? You will get a bucket number. You will get an index number, right? So same things we have discussed yesterday for the hash map. Okay, same thing will apply for the linked hash map also, right? Same thing will apply for the linked hash map also. Let us do this. Okay, let us try to do this. Okay, so this was the formula that we have used. So these are the internal things. You just focus here. Okay, what I am trying to do here is I am the size is 16, default size. Okay, so the key is Russia. Russia will be, the key will be converted to an hash code, and we get the hash code, and we perform the modular operation on top of this hash code, on top of the integer value that we have got, right, on top of this integer value. And due to this is called as modular operation. Modular operation will be done to get the index number, because you cannot use this hash value as an index, because it is a very big value. You need to convert it to a small value, and that value should be in between 0 to 15, because the default size is 16. So this is the formula to achieve that, right? When I run this code, so what is the hash code? I mean, what is the hash value that we have? So this is the hash value, right? And what is the index number that we got? 11 is the index number that we got. Okay, we got the index number as 11. For what? For the first key value pair. For the first key, I can say we got the index number as 7. Right? What will happen behind the scenes? Earlier we were discussing about, this time what will happen is a node will be created, guys. Okay, so let me put those values here. Okay, just for the reference I am putting it here. Okay, what will happen is file import to canvas from a file. Okay. A node will be created. Okay, this is called as node. Focus here, guys. A node will be created, and in this node, okay, the middle part, okay, it has been divided into 5 parts. It has been divided into 5 parts. Okay, one part is going to store the key, which is Russia. Russia is the key, right? Right? And the second part is going to store the hash value. What is the hash value that we have just copied from the, this is the hash number, isn't it? Second part is going to store what? It is going to store the hash number. Okay. And the third part is going to store the value. What is the value of Russia? Moscow. Okay. And this value, this is the beginning of the node. Okay, the entire part is called as a node. Focus. The entire part is called as a node. Okay, this node is going to have 5 pieces of information. 3 pieces of information has been occupied already with key, with hash number, with value, right? And since it is the first node, since this is what? This is the first node. The first part is going to have the null. Or no, not null. It is called as first. Okay, or you can call it as yet node. First node, yet node. Okay, and this is going to have a value called null. So focus here. A node will get created. A node will get created for this first line of instruction. For this instruction. So we are trying to add country Russia and the value as Moscow. A node will be created with this with a kind of this many information, like the country, the key, value, hash code, and something like null. Since it's the first node, you call it as yet. This node will be stored what? This node has got an index number, isn't it? What is index number? 11 is index number. Right? This will be settled in the index number or the bucket number of what? 11. Okay, where is 11? So this is where the 11 is. Okay, this will be settled here. Are you getting this? So let me repeat this. Okay, we are able to generate a node. Okay, this node is going to have the key information, value information, and the hash code information. So this is called as an hash code, right? And since it is a first node, you call it as yet, right? And it has no reference to the next node, so it is called as null. I will tell you why it is called as null. Okay, let me take a copy of this for the time being. Okay, let me keep a copy below here, somewhere here. Okay, so this node will be settled in the generated index number. What is index number that has been generated? 7 is index number, isn't it? Right? So 11 is index number. I'm sorry, it's not 7, 11. So this will be settled in the index number. right? Successfully settled. This piece of information has been settled successfully in the index number 11. Right? Now we are done with the first line. So let me remove this. So we do not want to deal with this line also anymore. Let me remove this. Right? Now we have 3 more lines to be executed, and we need to understand how it is getting work in the Bangalore. Second key is Canada. Right? Convert what? Convert the key to an hash code, and you get an index number. Right? So this is the hash code of Canada. We place it here. It's a positive number, and the index number is 14. Isn't it? So let me copy this. Let me copy this and let me put it in the main screen. 1 minute, guys. It's not getting copied. Okay. So it is copied. It is in the main screen. Okay, now listen. Same thing. I'm going to repeat the same thing. Okay, a node. We need a node, right? A node will be created, right? This node is going to have key information. What is the key information? Canada. Okay, and the hash code information. What is the hash code that we got? A big number, very big number, isn't it? So this is the hash code information, and we also have the value information, which is Ottawa, right? And this is the second node. Already we added first node, and this is going to be what? This is going to be second node. So previously in the first node, the value that we have here is null. Okay. Now this time, as soon as you add the second node, what will happen is this will not be null anymore. Okay. So this will become what? This will be becoming the address of this node. We can call it as what? Next. I will tell you what is next, and this is called as what? Previous, and this is called as what? Next. I will tell you what these values are. Since it is a doubly linked list, it is going to store two set of information. One is the address of the previous node. Second one is the address of the next node. For now, since there is no third node, so it is going to be null itself. Right? And again, this node will be stored in the generated index number, which is 15. Okay? Let us store this in 15. Before that, I want to store this somewhere here. This is second node. This is the first node. This is second node. So I want to store this in the index number 15. So let me rotate this 90 degree. So we have 15 here. Okay. So this will be settled here. Done. Right. Let me remove all this. So we have to deal with two more data. You will do it very quickly. So people who are not understanding, you can ensure that you will get this information here. Okay, the third is country India. You need to convert India to the hash code, and you will get the index number. Let me run this. So this is the hash code, right? And this is the index number. So, listen to me. You don't perform all these things. Okay, we are trying to understand what is exactly happening behind the scenes. Okay, so this is for country India, isn't it? So let me copy all this in the paintbrush. Right? Okay, and for this again a node will be created. Let me import the node. Right, this node is going to store 5 set of information. Okay, one is the key, which is India. Okay, second one is the hash code. I mean the hash value. Right, what is the hash value that we got for India? This is the hash value. Right, and this is the hash value. And the value for the country key India, which is New Delhi, right? And this is going to refer to the next one, and this is going to refer to the previous one. Okay, this is node number 3. This is node number 3, right? And this will get settled where? Let me paste it here. Okay, since this node number 2, this is not the last node, isn't it? So this will be not null. Now this will be next. It will be pointing to the next because we have got a new node, right? And since there is no other node after India, so this node will be pointing to a value called null, right? And this will be added in the generated index number, which is what? Which is 7, right? Let us try to add this in the 7th index. Where is the 7th index? So here we have the 7th index. Okay, this will get settled in the 7th index. Right? Done. Now last one. See, something will happen. Okay, this is the last one. Okay, what is the last key value pair that we have? So we have Japan and Tokyo, right? So let us try to identify the hash for Japan country and the index number for Japan country. Okay, this is the hash code. This is the hash. By using the hashing mechanism, you have got this number, and the index number is generated as 6. Right, this is for the country Japan. Right, let us copy this. Let us go back to the paint screen. Okay, let us try to visualize this, how it is getting stored internally. Okay, we need a node. A node will be created. Okay, I want a node to be imported. This is the node, right? And this node is going to have what? Key value, key as Japan. Right, and value as Tokyo, right? And after this, it is also going to have the hash number, hash function, the number that has been generated from the hash function. Okay, this is the number, right? And this is going to be previous, and this is going to be next. Next. Right? Let me have a copy of this. Okay, this is the copy of this, and right, this needs to be stored. Okay, since this is not going to be null anymore, this is going to be next because we have added the new node, right? So this is going to be next. Okay, next, and this is going to be null because this is the last node. Now you see, right? So this will be settled in the index number. What is index number that we have? 6 is the index generated index number. So this will be settled in index number. Index number 6. Rotate. Okay, so what I just said in the beginning of this class, I said it is internally it is going to use the hash table as well as doubly linked list. Doubly linked list. So what does it really means? Okay, you have added 4 elements in the form of key value. Okay, what is element that you have added? The first element is Russia, second element is Canada, third element is India, fourth element is Japan. Okay, a link will be created, a doubly linked list will be created. Okay, so this is going to have the connection. Okay, this connection says the first node as the address of the next node, right? The next node, the second node as the address of the next node, which is the third node. The third node as the address of the next node, which is the fourth node or the last node, right? And the last node has nothing. Okay, the last node has nothing, so you can call it as what? Null. Okay, this will be pointing to null because no more elements are added after this node, right? And you also call this as what? You can call this as tail. So when I say tail means the last node. Last node you can call this as tail, and the address of the last node is going to be null, right? The address of the first node is going to be what? 8, because 8 is representing the first node, tail is representing the last node. Remember, please remember, these are internal things. No need to focus much on this. Just try to understand why it is following the insertion order. So this is called a set. right? So when I get first node, okay, I have the information of the second node. When I get second node, I have the information of the third node as well as the first node, because you have two pointers here. It is pointing to the next node, and also it will, the next node will have the address of the previous node. The next node will have the address of the previous node. So there is a doubly linked here. That's why it is called as what doubly linked list. Okay, the moment you start to print, okay, let me remove this. The moment you start to print system.out.println, and if you try to print the reference variable, actual countries is the reference variable here, isn't it? If you run this code, you will get the insertion order is preserved: Russia, Canada, India, Japan. Why the insertion order is preserved? Okay, the retrieval will start from the head node to the tail node. What does it mean? A cursor will be created. Okay, this cursor will try to find the head node. So this is the head node. Okay, it will collect all the information. What is the first key information? Russia. Okay, Russia will be collected and displayed in the console. What is the second key information? Key information is Canada. Okay, Canada will be connected and displayed in the console. Okay, what is the third key information? Because it is traveling from head node to the tail, head to tail, India. So India will be retrieved, the key will be retrieved and displayed in the console. Key means along with the key and value, both. You can consider both. Okay, I'm just considering key here. The last node is what? Okay, this is Japan. Japan is the last node, and the key is what? Japan. Japan will be retrieved and displayed in the console. Okay, along with this key values, it is also going to get the values also. What is the value of next node? Nothing is there. Why nothing is there? Because this is the last node. How we can confirm this is the last node? You internally, it is specified as the type tail. Tail is a pointer where it says it is a last node. It is a pointer where it says it is a first node. Are you getting this? Okay, so this is how it is maintaining the insertion order. Okay, the elements that you have added here will have a link from each and every element. Okay, this is country Russia, right? Russia will create a link to Canada. Okay, and Canada will create a link to what? To India, because that is the third element we have added, right? And India will create a link to what? To Japan. Okay, indexing is different. Okay, indexing, according to indexing, we have got different indexes. The order that we have added is different. So Russia has got a different index number. Canada, India, and Japan got a different index number. What is index number that was given to Russia? 11 is index number that was given to Russia. What is index number that was given to Canada? 15 is index number. What is index number that was given to India? 7, and for Japan 6. Okay, index wise they have got different indexes. But if you retrieve it according to the indexes, okay, if you retrieve it according to the indexes, 6 is for Japan. Okay, the order should be what? Japan, India, followed by what? Russia and Canada. But you are not retrieving it according to the indexes. You are retrieving it according to the doubly linked list, and you are starting from head to tail. Okay, there is two types of data structure here. One is it is following hash map hash table internally. At the same time, it is also following a linked list so that the insertion order is preserved. Or now, are you getting why why you are able to retrieve the data and why the insertion order is preserved? Yes, no? Are you able to get this? Can anyone answer? Are you able to follow? Right? So if you are getting an interview question like this, you should answer this point. What is that exact point you need to answer? It is maintaining insertion order because the internal data structure is hash table but as well as doubly linked list. Right? One more point is it is okay, the very important point. Okay, internal working. I will give you the notes, don't worry, I will attach this in the description. Okay, the one more point that we have is it will also, very important point, it will also maintain access orders. This access order, very new word, right? Insertion order, we know what is an insertion order, but what is an access order? What is an access order? We don't know that. What is an access order? Let me explain you this access order. So in order to achieve the access order, I will tell you what is access order, but in order to achieve the access order, okay, you will have to use the following constructor. Okay, what is that constructor that we need to use? A very important constructor, okay, because the linked hash map is not only for maintaining insertion order, but it will also maintain what? The access order. But we have to understand what is an access order. Insertion order is different and access order is different, or accessing order, I can say. Okay, please put some focus here. Accessing order. What is the constructor? Okay, what are the constructor that we have studied so far? Okay, these are the constructor. Now I am creating a fifth constructor. Okay, fifth constructor, public linked hash map, and here you are going to pass something like the integer capacity will pass, and you will pass float, load factor you will pass, and you will pass what? A boolean value is x. Is accessible. Okay, so what is this? Let me go back here. So the constructor is what? Let me remove this. Let me remove this. The constructor is, first constructor is talking about the capacity. So I want to keep this capacity as 16. No issues. And the load factor, I want to keep the load factor as 0.75f. Okay, and I want to enable, I want to give the value. Okay, I have passed three values here, three parameters here. The first parameter talks about the capacity 16. Second parameter talks about the load factor. Okay, the moment it consumes 75% of the space, the size will be doubled. Load factor talks about that. The third one, I have said something like true. For timing, let us see if I keep it as true, what will happen? Let's see. Okay, now you see, I have added 4 elements by using Russia, Canada, India. I mean, by using the data like Russia, Canada, India, and Japan as keys. Okay, now what I am trying to do is, so I am trying to use the get method. Okay, so I am trying to use Russia. Okay, I'm using a get method and I'm passing the parameter key as Russia, and I'm passing the parameter Canada. Okay, now you focus here. This is a put method. Means 4 key value pairs has been added. 4 key value pairs has been added because 4 put methods. So 4 key value pair has been added. I'm using get method. Right? I just use get method. And I says I want to get the value of Russia and I want to get the value of Canada. But I am not printing it in the system.out.println statement. Now what I am doing is I am printing the actual countries here. If I print the actual countries here, we always think that it is going to preserve the insertion order because that is the exact takeaway that we have been discussing so far. Linked hash map means insertion order. But if you see what will happen, if I run this thing, what was the actual output that we got previously? Okay, previously we got Russia, Canada, India, Japan. Now you see the output. Okay, we are getting something like India followed by Japan, then we are getting Russia, then we are getting Canada. Why this is happening? Because the priority is getting changed. Okay, so we have started accessing the key Russia. Okay, this is the access. We have accessed Russia, right? And we have also accessed Canada. So what the theory says is the most recent access. So this is the most recent access. Most recent. We have access to 2 elements. One is Russia, second one is Canada. But Canada is the most recent access. So comparatively, when you compare Canada with Russia, according on top of accessing the keys, it is the less recent access. Right? So this is the latest access. Canada is the latest access. For example, when you are visiting two places, okay, last month you visited Andhra Pradesh, okay, this month you are visiting Karnataka. So I can say that, okay, recently you have visited Karnataka. Can I say that? I can say that recently you have been to Canada, I mean Karnataka. Because you have also visited Andhra Pradesh, but not recently. That was just before visiting Karnataka. Likewise, I'm accessing two keys. One is Russia, second is Canada. But Canada is the most recent access. Right? So these two will not get priority. Okay? Russia is here, Canada is here. Right? So we access these two. Okay, what are the elements that we haven't accessed yet? India and Japan. So India will be printed, Japan will be printed. Okay, less recent access will be printed first, the most recent access will be printed last. Okay, this concept is called as what? Preserving accessing order. Preserving accessing order. You access something, okay, that key will not be given priority. Okay, the elements that has not been accessed yet, that will be given priority. So India is not accessed, so India will be given priority. Then Japan, okay, then Russia, then the most recent access element. Okay, we will see a few more examples to understand this. Okay, this concept is called as what? The preservation of what? Accessory entries, recently accessory entries. If I try to do, for example, instead of Russia, if I give Canada here and if I give Japan here, okay, and if I try to print actual countries, right? So what is the order that is going to give? Russia will be printed first. This Canada and Japan will be ignored. They are already accessed. So Canada and Japan will be ignored. Russia will be accessed first. I mean, second is Russia will be printed first. India will be printed next. Right? The most recent access element will be printed last, and just before that Canada was accessed, that will be printed there. So the order is going to be Russia, India, followed by Canada, followed by Japan. Okay, Russia, India, Canada, Japan. Right? You can achieve this. Okay, you can achieve this by using what? By using this construct. If you define a constructor that accepts three parameters, and the first parameter is the capacity, second parameter is load factor, and third parameter is what? The representing the Boolean value, which is defining that it is enabling the accessing order. This is what? Enablement of what? Accessing order. So you are enabling what? Access order. Right? By creating a flag as true. Right? So if you want to understand this in the main screen, very simple. Okay, what is the order of element that is added? Okay, Russia is the first element. Canada is the second element. India is the third element. Japan is the fourth element. So this is the order. This is order number 1, isn't it? And you have 2, and you have 3 here, and you have 4 here. 4 countries. So you are using a get method, guys. You are using what? You are using a get method. Right? Get method, and you are calling Canada, and you are calling Japan. Right? So this is the Canada. You are calling these two keys, Canada and Japan. Okay, and you try to print the reference variable. Reference variable. What are the elements that will be displayed in the console? What order it is going to follow? Okay, the first order first is Russia is not at access. Then India is also not at access. Right? Followed by the less recent access. Canada was a less recent access. Then followed by the Japan. The latest, most recent access will be the last element that will be printed. So this is order: Russia, India, Canada, and Japan. That is what happened here. Okay, if I take another example, like if I want to take here Russia, and let the Japan be here itself. Okay, the order is going to be what? Russia has been accessed, Japan has also been accessed. What are the elements that are not accessed? Canada and India. So Canada will come first, India will come second, followed by Russia and Japan. So Japan is the latest element that is accessed. Canada, India, followed by Russia and Japan. Are you getting the functionality of are you getting how to enable the access order? So this is how you enable the access order. Are you getting this? Okay, so I want to keep this constructor. So very important constructor, fifth constructor. Okay. So usually we use this constructor just in the computer caches. So you have caches, no? Computer will do some caches, browser caches, system caches, something like that. So they keep in priority order. The order will be maintained in the caches. So to represent that order, they use this access order mechanism. That's it. So mostly you don't use in the programming languages, but for your understanding, this is one of the concepts that you have that is associated with the linked hash. Right. So let me remove this. Okay. What is the point? Enabling access order. So to create a linked hash map, that maintains the access order, not insertion order, access order. You will have to use the constructor that takes 3 parameters, which is what? Capacity, load factor, and the access order enablement. Access order flag. You can use true or false. If you are using true, it follows the access order. If you are using false, then no, it will not follow any order. If you are using false, no matter what, it is going to maintain the insertion order. No matter how you have access of that element, okay, it doesn't even matter. Right? It always going to maintain the insertion order. See, insertion order is maintained. Okay, but if you change the flag to true, okay, access order will be maintained. So we have an option to enable or to disable. Access order is maintained. Right? Back to true. So what is the constructor that we have? So this is the constructor. It's accessible, or I can say that access order. You are going to use a flag. You can define it true, or you can define it as what? False. Right? So use cases like why one has to go for this access order. For the reference, you can say we can use it for LRU caches. Right? You can also use it in the priority systems. These are the network level programming in your systems. So this LRA caches is particularly useful in implementing the least recently used entries. When you want to eliminate the least recently used entries, you can go for LRA caches. Just for the reference, you keep this, and you can use this in the priority systems. The priority systems are like when you are accessing the elements more frequently, or when you need to prioritize some elements frequently, right? So that is called as what? Priority system. Okay. So that's it about the internal working of the linked hash. Right? You are not getting it.